Hey guys, Miss Sablo here. I want to talk to you a little bit about the periodic table of the elements. As you can see, here we have a periodic table of the elements. Beautiful colors. You know how I like those colors. I would highly recommend that you get this one from the internet at webelements.com and you bookmark this site, because if you need a periodic table of the elements, this is one of the best online versions I've found. First thing I want to talk about with the periodic table is that it's a group of atoms that we found. There are about 95 naturally occurring. The rest are created in laboratories. And these 95 atoms plus the others, they make up all the matter in the universe. And everything is made of matter. You matter, you're matter. Get it? Got it? Good. So we've got the arrangement here of periods going across. This is period 1 with just 2 elements in it. This is period 2 with 8 elements in it. Period 3 also has 8 elements. Period 4, period 5, period 6 comes across here and then jumps down to grab the lanthanoids. And then period 7 starts here, goes all the way across, but it also jumps down and it grabs the actinoids right here. Mostly we're going to be concerned with these tall groups here. Groups are the atoms as they go down. 1, group 2, group 3, group 13 on this. Some places, some periodic tables call this group 3, but group 13 here, 14, 15, 16, 17, and 18. These are the periods, and these are called the representative elements. Down here, these short ones we won't be concerned with so much right now. These are called the transition metals as a group. So these are the transitional elements. I want to point out to you a couple of other things. Notice that these numbers here, 1, 2, 3, 4, 5, they're arranged in order of increasing atomic number. These atomic numbers, the 1, the 3, the 4, 5, 14, 33, etc. These numbers on top of this periodic table represent the number of protons each atom has in its nucleus. Now, the number of protons an atom has can never change for that atom. If you change the protons, you change the type of atom or element that you have. So the number of protons and the atomic number are always going to be the same. For example, every atom of nitrogen, 7 protons. Every atom of carbon, 6 protons. Now, usually, for our purposes, atoms are neutral, and we're going to talk about the number of protons in the nucleus equaling the number of electrons that are found outside of the nucleus. These numbers down below, these are called the atomic mass numbers. Now, these are actually a weighted value of all of the naturally occurring isotopes of an atom in the relative amounts that they occur. We're going to use them to calculate the number of neutrons an atom typically has in its nucleus. So, for example, here for oxygen, the mass number is 15.999. We're going to round that to a 16 because I either have a whole neutron or I don't have a neutron. So if I have 16 is the number of protons plus neutrons, and 8 is the number only of protons, when I subtract these two, I know that oxygen has 8 neutrons. Let's take a look at another one. Here's beryllium. I have 4 protons in beryllium, and I have an atomic mass number of 9.0122. We'll round that to 9. So the number of protons plus neutrons in the nucleus is 9. I subtract that from the number of protons, and I get that berylliums typically have 5 neutrons in their atom. Alright guys, I think that's enough to be getting on with for now, so I'll see you later. Bye.